Hello, I'm Eric Snodgrass, and thank you for watching today's long-range technical forecast video for Australia brought to you by Nutrien Ag Solutions. This analysis is being provided for perspective only, and any decision made based upon this presentation is the sole responsibility of the person making the decision. Finally, please remember that all long-range weather forecasting is speculative by nature. Now, before I dig into what's going on across Australia, I would like to just let you know of a pretty substantial event that happened across the United States, right in the heart of our main ag belt. On August 10th, we had an event we call a derecho. This is a long-lasting, large squall line of thunderstorms, and this is just kind of a time-lapse view of what they look like. In animation from our national radar network here, you can see the storms raced right through some of the most productive ground that we have in the central part of the United States. And these long squall lines, like you see here on radar, produce a tremendous amount of damage. And this is how they do it. So I got a diagram here of what one looks like if you cut it in half. The storm motion, as you see here, moves to the right on this page, which generally for us is toward the east away from the west. What you have to look out for is on the back side of these storms where all the rain is produced, there's this feature called the rear inflow jet. And as the rear inflow jet comes racing underneath the storm, it kind of rears itself right at the very front of the storm and produces these pretty dramatic clouds. We call these shelf clouds. They're kind of a warning. They tell you you've got just a few minutes to get inside before the nasty part of the storm gets there. Now take a look at this. This is a radar image zoomed in central Iowa. And here you can see the leading edge of the storm on a radar reflectivity image. Remember, when you look at these maps, the colors tell you how intense the rainfall is. But our radar network has Doppler capabilities, which means we can measure the wind speed and direction of that precipitation. And right here was the rear inflow jet, and we measured wind speeds coming into the backside of the storm at 122 miles an hour. And that storm started in Iowa and cut through Illinois and actually ended up on our eastern corn belt. So the damage looked like this across a 700-mile swath right through the heart of our corn belt. And what we can see here is damage to the infrastructure, like these grain bins in Iowa, and also so much of our corn crop and soybean crop in the mid part of the country here just laid flat, like you can see here in this picture that's over there on the right. The damage was so extensive we could actually see it from satellite, and I'm kind of outlining where we got a clear picture the other day of some of that damage. And just to give you some perspective, there's somewhere between 8 and 10 million acres of corn and soybeans inside of that area that I just circled. And a lot of these systems actually did make it over here to Illinois, almost to where I live, which is right on the corner of this image in a town called Champaign. So when you look at this overall, I wanted you just to keep aware of a significant event that happened just recently in the United States. Now, just the day before this happened, we were watching some pretty strong winds in Australia as well. Take a look at this wind map from the 9th. When you take a look at the large systems that were surrounding Australia, the one I want to focus in on is this one right here, putting some pretty strong winds into Sydney. And on several of your news broadcasts, we saw some great imagery like this of where some of the waterfalls were being blown back up over the cliffs by the strong winds. So these were some widely shared video here coming out of Australia that many of us in the United States found quite fascinating to watch here. So with that as a backdrop, let's take a look at the last week's worth of total accumulated precipitation. Feel free to pause the video and take a closer look at your region. But we can see widespread rains overall just in the last week here. Some of the amounts range anywhere from the 10 to 25 millimeter range, but there was a couple of places in New South Wales, especially when you get down there into the southeast corner, that saw over 100 millimeters of rainfall as of late. Now thinking about that and putting it in the context of root zone soil moisture, the map that I'm showing you here shows us where we currently stand across Australia's growing areas in terms of what our soil moisture indexes look like. And you can kind of pick out some of the regions that have been quite dry. For example, in and around those fields near Adelaide, quite wet, but in large sections of New South Wales, even in parts of Victoria, we do see above average, in some locations very much above average soil moisture at this point. Now what I'd like to do is something a little different. I'm going to break away from my presentation for just a moment. I'd like to take you to a web page here. I want to show you something that I hope you can start to use. So I'm just going to go to Google here, and I'm going to type in NASA World View. So I'd like for you all to do this at some point. And when you do it, you'll get a list in the search engine, and click on the first one, EOSDIS Worldview, okay, or the second one, Worldview NASA. They're both the same exact link. When you click on it, you're going to be brought to a page like this. Now immediately just go up and click the X from the welcome window. And what I'd like for you to do next is I want you to just kind of browse around and take a look at some of the recent satellite data. You can come right over here. The date is August the 12th, as you can see here. And I can see some of the high resolution satellite imagery from today. Now, this is from our low Earth orbiting research satellites. What I would like for you to do, though, is this. Click right over here. See where it says Add Layers? Click Add Layers, and you have all of these options. Feel free to explore. It's a great website. But come right up to the top and type in NDVI. That's what I want you to do. And then I want you to click right here in this top box, which says Normalized Different Vegetation Index on an 8-day rolling index here from Terra Modis. That's the one I want you to do. So click on that. It'll show up. Close the link, and now you got to go back 1 day to see the data. So here it is. So all I did was I clicked back 1 day. Now for me, I have trouble sometimes seeing these gradients in greens. So what I like to do is I like to change up the color bar. First of all, I'm just going to take the clouds off so it's a little clearer here. So I just click that close eye button there, and I'll come right up here and see this. Click on that, and then you can change your color bar to whatever you want. I'm going to pick a divergent color bar, specifically divergent 1. There we go. And I'm going to close this up. Now, what's neat about this is I can then kind of zoom in. For example, I'll just pick, over here in this part of Australia and take a look at the high resolution data from the NDVI. And as I move the mouse around places, you can see that it shows me over here where I am. So if I'm in this particular spot, I've got very high values of NDVI. So in this particular case, red would be high values, blues would be low values. Now, here's a really cool thing that you can do. If you see over here, there's a thing that says Start Comparison. I'm going to click on that, and now I have 2 tabs up here at the top. One from 2020, August 11th, and one that went back to 2020, August 4th. I'm going to click on tab B, and instead of looking just a few days ago, I want to look, let's just go last year. So I clicked that. Now as you slide the bar across, you can see how things compared 1 year ago to today. So for example, let me show you what things look like 1 year ago over here at B. Notice how low the values are in the NDVI right in through this area. But as you then compare it to 2020, now you can start to see how much higher they are in that place that has received quite a bit of precipitation. So I just want to show you a tool and encourage you to use it and play around with it because it is a great resource. And you can pause the video, watch this again just to get those instructions. Now with that, let me get back to my presentation here. All right. We were talking about soil moisture, and now what I want to do is I want to address those things that have changed a lot since we last talked a couple of weeks ago. So the big features that I've been watching move quite a lot are really happening in the tropics, specifically with the Madden-Julian Oscillation, which you can see over here on the left. Now, from the end of May through almost the entirety of July, the Madden-Julian Oscillation was stuck over in phase 1-2. Now, what does that mean? Well, phase 1 and 2 is over Africa, here in the western part of the Indian Ocean. And when it's there, you can actually see the correlation between precipitation. So take a look down here. Here's phase 1 and there's phase 2. So a lot of convection happening here in this particular part of the Indian Ocean. So it spent 2 months there, 2 solid months there, before racing out at the end of July over here into phase 3 and 4, before curling back to where it currently sits today on the 12th, right here close to what we call the null zone. And it's heading itself back to, that's what these kind of yellowish, greenish lines tell us, back over into phase 1 and 2. Now the movement that we saw here out of phase 3, 4 into 5, well, you can see what that does to precipitation. Notice getting over to phase 3, 4, and 5, it tends to increase precipitation amounts that are in Australia, north of Australia as well. But if we go back over to phase 1 and 2, that could signal, if it gets stuck there, maybe a pattern like we did see throughout much of the month of July. This is one component to this overall flow. So I went back and I looked at when it changed. So remember, it was the end of July through about this point in August. And during that time period, we saw higher than normal pressure to the south of Australia and lower than normal pressure here across much of Australia. And this is what helped along some of the heavier precipitation amounts that we saw as of late, the movement of the MJO. So I start to ask myself some questions about where it is going. And so we're going to take a look at this. If it does move back over into phase 1 and 2, this is what we end up getting. Focus on the image over there on the right. When we look at these colors, the bluish greenish colors represent where there's good upper level support for rising motion in the atmosphere. So again, it's over Africa and this part of the Indian Ocean. Where we tend to see more suppression of upper level motion is here. And that means the atmosphere, it's kind of got like a lid or a cap in the upper levels trying to keep it from exhausting easily into the upper levels of the atmosphere. And when I start to see that, it gets me thinking about what is the relationship between the Mount-Julian Oscillation, El Nino La Nina, and the Indian Ocean dipole. So let's go over to the El Nino La Nina first. Over the next 15 days, which is what we're seeing over here in what we call a Hofmüller diagram, what I notice is right in through here, there are some red colors showing up on this diagram. And in through here, we have the blue colors. Now, what does that mean? Well, above this area, right in through here, we're expecting going to the east stronger trade winds, while here in the Central Pacific going over towards South America, we're expecting to see stronger winds out of the west. What's happening is near the surface, they're leaving this area. Okay, it's spreading out, diverging. And that is why in the upper levels of the atmosphere, the air is collapsing and sinking in over the top of this. You see, this interaction between the trade winds and the MJO is very closely linked. And so we start to ask ourselves, well, does this mean we're going to get a bit of a change in what's been happening with La Nina? Because over the last couple of weeks, this region in particular, as well as this area off of South America, has been cooling. You can see it here. We have gone from the end of July now to the middle part of August, seeing our temperatures here in the middle part, what we call Nino region 3.4, showing up now at negative 0.5 Celsius. That would be actually weak La Nina territory. At the same time, when measuring the pressure differences between Tahiti and Darwin, we've seen the Southern Oscillation Index go back positive. It's not yet up to that +7 mark, which would say this is really a La Nina-like pattern, but it is at least signaling that the La Nina was trying to get going. But I think La Nina has been playing second fiddle to the MJO in its movement. And when we think about this in broader context, we do notice that the longer range forecast for September, October, November, that's what we're looking at here, does try to keep those cooler waters in place. You see the warmer waters here just north of Australia and possibly near average to cooler on this side of the ocean. Now, what does all that mean? Well, it could mean that we go into weak La Nina as we progress through September, October, November. All of the models currently run around the world do at least suggest that we go toward that cooler side of things as we move forward. Now, this is why I'm telling you all of this. That signal will dominate long-range forecasts for September, October, November. So if this La Nina doesn't materialize and if the MJO continues to be the dominant signal, we cannot trust these long-range forecasts fully. I'm going to show them to you in a moment, but I want to put that bug in your ear right here. So when I think about all of this, I'm having a difficult time finding a good analog to this particular pattern. And it's also got me thinking about what's going on in the Indian Ocean. So let me get those drawings off there. We see that several of our longer range models here want to keep the Indian Ocean dipole on the negative side of things, except for BOM. BOM right now is trying to keep Indian Ocean dipole right here towards neutral conditions. We can see what that means when we look at the European model, which would be reflected in this forecast right here, as for those temperatures across the Indian Ocean. So I think things are kind of hanging a bit in the balance, and the IOD and ENSO, or La Nina, is really going to respond to what the MJO is going to be doing. We have another component to this, the Antarctic Oscillation, or the Southern Annular Mode. It crashed down here at the beginning of August, which we talked about last time, and it's forecast to make a recovery back up toward normal conditions as we progress here into the middle and end of this month. So putting that all together, let's just look over the next week at what precipitation anomalies are going to look like. You can see wetter than average conditions in parts of New South Wales and Victoria and southern Queensland. We can see, and this will be critical right here around Adelaide, to get some wetter than average conditions as well. And it appears that we need to be watching for systems to come into the western side of Western Australia. Let's see what that looks like by animating total accumulated precipitation through the next 10 days. As we get a glimpse of this pretty active pattern that's moving across here, we can see when those rainfall amounts are expected to get to these specific regions. And overall, we see that in parts of New South Wales, there's a pretty broad sector there that could be getting upwards of 10 to 40 millimeters of rain, with much heavier rainfall down here, of course, being aided in the lift by the mountains or by the higher elevations. So to see this all play out in kind of real time here, I'd like to show you the high-resolution NAM model and its forecast. We're going to start here at 12Z on the 13th. So we do have a low just to the south here, relatively deep low. And as we play this forward, let's pause it here and step back and watch this move. So going from Thursday into Friday, we can see I'm rocking back and forth here, relatively heavier rainfall amounts in places in parts of New South Wales. We can also see scattered showers down here in this part of South Australia as well into parts of Victoria. We then see the next system as that one exits here by late in the day on Friday. The next system bringing in its frontal boundary on Saturday right here in Western Australia. So this particular low following that high could possibly be bringing in some rain showers to a broad sector here in this part of Western Australia. Going from Sunday into Monday, now into Tuesday, we see, now into Monday morning. Wait, that's Monday morning for me. It's later in the day for you all, We're going to be seeing quite a bit of chances here for more scattered showers. Not heavy rainfall, but some scattered showers down in this part of South Australia. Going forward now into Tuesday, we see once again with that low still sitting off the coast, better chances for showers. As we move forward here into the middle of the week, this is Wednesday, getting into Thursday and Friday, we continue to see throughout the week better chances for rainfall here in parts of New South Wales and Victoria as we move forward. But that takes us out pretty far in this forecast to August 21st. I do want to mention one thing. As that system goes racing here, which we just saw, the potential for some stronger winds along the coast does exist. We could be getting some wind gusts here upwards of 70 kilometers per hour at times, with some much stronger winds just offshore. So please be aware that with this next system coming through, we could get some stronger winds. But what about looking out at week 2? The European model, once we get into week 2, which is when we start to see this, the southern annual mode go back toward neutral values, when we start to see the Madden-Julian oscillation go back over to phase 1 and 2, what the European model is painting for us here is not nearly as wet of a picture as what we have been seeing. But the GFS model is on Saturday, August 22nd through Monday, August 24th, trying to bring in another system in through this area. Now, at this point, I don't have much confidence in that forecast, so we're going to have to watch it very carefully. But this is what the global models that we like to look at here suggest when we get out here into the second full week of this forecast. In terms of temperatures, what we have over the next 5 days is we got quite a bit of warmth over in parts of New South Wales, getting into the northern part of Australia, but the cooling down begins here in the west first. As we then stretch this out to the day 5 through 10 pattern, that's when we saw the very active cyclone moving to our south here, our low pressure system, and it was overall just a slightly cooler than average pattern during that time period. The models continue out to days 10 through 15 to keep parts of Victoria, New South Wales, southern Queensland, and parts of South Australia on the cooler side of things as well. So it's not as though we're going into a time period here where we're going to be seeing an abundant amount of above average temperatures. Much of that will be confined to northern parts of Australia. So let's stretch this out even farther. September, October, November long-range forecasts were just released. And it's interesting to see how well the European ensemble, which is what's on the left, is in agreement with the probability of exceeding median rainfall over there on the right. I'm seeing a lot of similarities here in the patterns being picked up by BOM and by the European model. And this is also shared by the National Multi-Model Ensemble. If you see here down in Australia, it's also got a better chance for being wetter on the eastern half of Australia. So we need to keep this in mind. What I would like to make the case of is that this particular forecast is consistent if we do have La Nina conditions maybe dominating the pattern. And as I have stated, this La Nina is weak at best, and it's very difficult to find a good analog to this one, given what's going on in the North Pacific and what's going on in the Indian Ocean. So I think this all kind of hangs in the balance. Should that La Nina really not be to the strength that the models are forecasting it, and instead the MJO decides how the precipitation patterns are going to adjust, then we could see a different pattern than this. How about temperatures? Once again, I see some pretty good, similarities here between what the European model's saying over September, October, November, and what BOM is saying. Notice a similar pattern: warmer north with near average to cooler than average, stretching from west to east here across the southern half of the continent. And that is also echoed in the National Multi-Model Ensemble. Now, why I do this is because the models that are in the NMME, BOM, and the ECMWF are all separate modeling centers. They're not sharing this information. So when we see some consistency, I just have to come back to the idea of maybe they're all resting too much on the continued development of this La Nina. Should it continue to develop, then I think we got the green light for giving this forecast better odds of happening. But at this point, I think it rests on the competition between La Nina and the Madden-Julian Oscillation. I'd like to finish with a quick bit of international information. First of all, in Europe, we have had some drought conditions in France and Germany, and they are in the middle of a pretty massive heat wave right now. Storms will be popping, though, as that heat wave transitions out. And the last place I would like to take you here is China. So you've probably been hearing in the news about the incredible rainfall that's fallen on the Yangtze River and the river basin surrounding it. From June through middle August here, or early August, we have seen some places picking up between 45 and 60 inches of rainfall. This has caused a lot of flooding. The Three Gorges Dam, which is here, just to let you know, and this is not anticipated, but should it happen, there's 500 million people that are downstream of this that could be affected by a catastrophic failure of this particular system. And what we notice is that over the next 10 days, while it will be dry in through here, the northern tributaries and the western tributaries to the Yangtze River are going to continue to be very, very wet. So I wanted to keep you up to date on that international issue, and also would like to point out the advancement north in the Indian monsoon. It has really progressed farther to the north and, compared to normal, extremely wet here just to the south of the Ganges River Valley into this section of India. There has been actually a lot of reports of flooding from this year's monsoon. Okay, thanks for giving me some extra time tonight to kind of talk with you about the longer range weather. I hope that you all have a good next couple of weeks, and I look forward to preparing that next update for you. Have a good one. Thank you.